Hello math peeps. So I'm going to real quick just go through what the answers should have been for this, and then I'll go through the work. So if you got your answer right and you don't need to see me work through it, great, skip it, do whatever you got to do. So first one should be an enlargement with a scale factor of 3/2 or 1.5. Second one, p prime is -8, -4, q prime -4, 0, r prime 0, -4. Number 3, you could have 8 over 4.5, 16 over 9, or 1.78. Number 4, perimeter of the yard is 130 feet, perimeter of the patio is 52 feet. Number 5, x is 30. Number 6, area is 6 centimeters squared. Number 7, they are by side angle side similarity, but you would actually need to verify a little bit of something about the sides and not just look at the outsides labeled. Number 8 ends up being 864 inches or 72 feet. We may have done this one in class. Number 9, you get 315 over 11 or about 28.63. And number 10, you get that y is 27. So here we go. Number 1, enlargement would mean it's getting bigger. So it is an enlargement, remember, because this one with the little prime is the image. So after dilation is this one. This one's the pre-image or the original. So to find the scale factor, remember that it is the ratio of image measurement over pre-image or original measurement. So scale factor for this one is 12 over 8. If you divide those both by 4, that simplifies to 3/2, or you could just straight divide them and get about 1.5. So this one is 1.5 times bigger than that one. And also remember that enlargement scale factor should be greater than 1. If it's a reduction, the scale factor would be, we're still talking positive, but would be less than 1. So number 2, all you have to do is just multiply the coordinates by the scale factor. So p prime, just multiply those by 4, and that's -8, -4. Q prime, multiply by 4, get -4, 0, and r prime is 0, -4. Alright, number 3. So again, scale factor should be image over pre-image or original or actual size. So this is going to be 8 over 4.5. And again, this, you can think of it this way, this would be an enlargement, so a bigger number should go on top. So this is kind of a weird way to leave your answer with a decimal inside a fraction. So to make that a little nicer, if you still want it to be exact or a fraction, we can multiply that by 2. And that one, and we get 16 over 9. And if you end up needing just more of an approximate answer, you can divide those and you get about 1.78. Or you could say that that's 1 7/9. That also works. Alright, number 4. So finding the perimeter of the yard is the easiest part, I'd say. So you just have to add up all the side lengths. So you have 2 that are 45 feet, and you have 2 that are 20 feet. So that'd be 90 plus 40, which is 130 feet. To find the perimeter of the patio, so the length should correspond with the length of the backyard. So one option would be to find the width of the patio by setting up a proportion using this ratio. Or what you can do that's a little bit faster or more direct is the ratio of the perimeters should just be the same as the ratio of the side lengths. So it doesn't matter which one you put on top or bottom as long as you're consistent across. So you do the side ratios. So you've got 18 over 45 is equal to the ratio of the perimeters. So it'd be 18 is the patio one, so patio should go on top. So perimeter of the patio that we're looking for over perimeter of the yard, which is 130 feet. And you could just go ahead and cross multiply those to start. Makes it a little bit easier for me if I simplify it first. So 18 over 45 ends up simplifying to 2/5. So 2/5 is equal to p over 130. So you could cross multiply at that point. That'll give you 5p is equal to 260. And then dividing by 5, you get that the perimeter is 52 feet. Another way you could get there is you could find out that to get from 5 to 130, that's multiplied by 26. So if you multiply 2 by 26, that also will get you to that value, which is still 52. So it works either way. Alright, number 5. So these polygons are similar. We need to find the value of x. So most of these you're just going to set up a proportion to do that. And you've got multiple options here. You just need to remember to be consistent. So if you're doing big shape on top, should be big shape on top on both sides, or small shape on top on both sides, whichever. and then corresponding sides go together in the same fraction. So you can do 21 with 14, or 18 with 12, and then x with 20. So I ended up choosing x over 20 is equal to 21 over 14, and again, you could just cross multiply, and there are other ways to go about it. I would simplify first, it makes it a little easier for me, so I get x over 20 is equal to 3/2, and you could just, that there's times 10, so times that by 10 gives you 30, or cross multiply. 2x equals 60, divide by 2, and you get x equals 30. Alright, areas. So, area is the ratio of the sides squared is the ratio of the areas. So, there are other ways you could do this, but if you want to set up a proportion, you take the ratio of the sides, so it doesn't matter again which is on top, as long as they're consistent. And that squared should be equal to the area ratios. So I'm looking for that area, so I'm just going to call that A. And then the area of this one is 96. So that's just 1/4. So 1/4 squared would be 1/16, and that's equal to area over 96. So you can cross multiply, you get 16a is equal to 96. Divide by 16, and you get that the area of that one is 6 square centimeters. The other way you can think of this too is that 12 to 13 centimeters, or excuse me, 12 to 3 centimeters would be divided by 4, so the area should be divided by 4 squared, or divided by 16. So 96 divided by 16, which is what we ended up with, gives you 6 square centimeters. Alright, number 7. So determining whether these are similar. So remember that we had 3 different shortcuts you can use here. So angle-angle similarity was one of them, side-angle-side similarity. So 2 angles congruent, you know they're similar. 1 angle in between 2 sides in proportion, those are similar. Or side-side-side if you have 3 sets of side in proportion. So the only even possible one this could be is side-angle-side, but we need to check to make sure that the side ratios are in proportion with this. So you want to be careful too, and remember that when you're setting up corresponding sides, because these are definitely not facing the same way, that you look at how the numbers compare to each other. So biggest number here should go with the bigger one over here. So 16 should be paired with 24 when I'm checking ratios. It doesn't matter again which one you put on top, and then 12 should be paired with 18. So I know the angles are congruent already, I just need to double check and make sure that the side ratios are. So if I do 16 over 24, you could just divide it to get a decimal, or simplify it to 2/3, and then if I check the other one, 12 over 18, that also simplifies to 2/3. If you'd done it the other way, you would have gotten 3/2 for both. Works either way. So that one is similar by side-angle-side similarity, and we verified it by checking the side lengths. So you do need to make sure they're in proportion. Alright. Number 8, I believe we did it in class actually, but we'll just check this one real quick. So you want to make sure that when you're setting these up that all your units are the same. So we've got inches and feet, so we need to change this to inches. So multiply 50 feet by 12 inches per foot, so that one is 600 inches. 5 foot 4 inches, that's 60 inches, plus 4, so that's 64 inches tall, and her shadow is 40 inches long. So we're going to figure out the height of the flagpole. So we got flagpole and a person. I always like to draw a picture. I'd recommend it. Okay, so this here, height of this person is 64 inches. We are trying to find the height of the flagpole. We know that her shadow is 40 inches, and we also know that the shadow of the flagpole is 600 inches. So we just need to set up a proportion that we can solve here. So just make sure your corresponding parts go in the same place. So I'm gonna do shadow. So it should be shadow of the smaller one over shadow of the bigger one is equal to height of the smaller one over height of the bigger one. And then you actually can simplify this. It'll make it a little bit easier, at least for me, and that's 1/15 is equal to 64 over x. So you can cross multiply, and that gives you that x is equal to 864 inches. It did want it to the nearest foot though, so if we divide that by 12 for 12 inches per foot, you get 72 feet. Nice and exact. Okay then, number 9. So you're trying to find zy, and remember from our theorems there's a bunch of different ways you can set this up. So I'm going to just call that x to make it a little nicer looking. So remember that if these lines are parallel, then the ratio of the pieces of one side should be equal to the ratio of the pieces of the other, or you could set it up with the ones directly across from each other in those pieces. So you could set it up with a, like 35 over 44 is equal to x over 36, and again, you just need to make sure you're consistent. So shorter piece, longer piece, shorter piece, longer piece, top and bottom. Or you could go with the ones across from each other. So you could also do something like 36 over 44 is equal to x over 35. Either setup should work. If you cross multiply and divide them, you get the same thing. I like this one because I can simplify it by dividing top and bottom by 4. So that gives me 9 over 11 is equal to x over 35. And then if I cross multiply at that point, I get that 11x is equal to 315. And then divide by 11. And if you wanted to keep it as a fraction, that would be just 315 over 11. Can't really simplify that. Or decimal-wise, it's about 28.63. So either one. And again, you'd get the same answer if you'd use the other setup. Okay, so number 10, also you can set up 2 different ways. You can either, so as long as this is the angle bisector, which it shows our markings here, you can set up the pieces of these sides to the full sides. So 18 over y would be 42 over 63, or you can do piece of this to that full side, piece to that full side. So you can either do something like 18 over 42 is equal to y over 63, or you could set it up something more like y over 18 is equal to 63 over 42. And you can cross multiply, solve it. If you're doing it with a calculator, simplifying doesn't really make that big of a difference, but I like to simplify things. So that one I could simplify to 9 over 21 is equal to y over 63. And looking at this, I happen to know that 21 times 3 is what gives me 63. So I can multiply 9 times 3 to get that y is 27. And you can get there doing it other ways too. If you cross multiply, whatever 9 times 63 is divided by 21 ends up giving you 27, or you could use the other setup and do it that way too, but either way you should get the same answer. So if you got questions, feel free to post them in the discussion or email me and work on your practice test. Alright, thanks, bye.